Right, so what I'm going to do is start off by opening our drawing, and I saved this as a DXF file. So let me make sure I'm not lying real quickly. Let's go to class review. And oh yeah, right here in the last class, class number 3. Now this says 3 of 3, but in reality, we were going to do this in 3 classes. These have all got to be retitled. They're actually 1 of 5, 2 of 5, 3 of 5. We're on 4 of 5 tonight. But on 3 of 5, right here is the display table. It's a DXF. So you can open this up in any CAD program, okay? Instead of, because the display table CRV is in the latest version of VCarve Pro, so some people couldn't open it, so we do have a DXF that'll work for you. I've also got an export right here, but to be honest with you, I wouldn't bother downloading this one right now, because I will download the new export and put it in the next class, and it will have, I probably will come back and even update this one, and it will have everything that we do up to tonight's class. All right. So with that, let's go ahead and take a look at the project. And just to recap what we've done so far, we focused, first of all, on the joinery, where we machined the square end and cut the mortises and showed off the mirroring capabilities in CCAM Pro that Mike put together for us. We've also worked on the tenons here on the rails, and we did an overall drawing and setup and established the program to begin with in CCAM Pro. So tonight we're going to follow through with the turning, and we're going to do the turning with the lamb's tongue and the bead here at the top, and then a taper on it. So we're just going to focus on that tonight, and then in the next class we'll come back and we'll import files for cutting the arches and maybe even the tabletop and everything, so that everything will be organized into the project in CCAM Pro. And just a reminder that this is a drawing of the 4-jaw chuck and the blank, and I have moved the X0 from the end of the blank, not from the jaws, but from the end of the blank. I've moved it out 1 inch. And so in this case, it says it's 28 from end to end, but the part is actually 29. So we're going to make it 1 inch longer, burn that inch, and cut it off. Now, I'll show you real quickly. Unfortunately, tonight's class, you can see, let me stop sharing real quickly. You can see this. Okay. You can see the part here, and this is just a couple sample blanks I had. We're doing all our testing on. So I'm going to measure that. And it's about 26¼ It's about 26¼ inches long. So we're going to test everything on this part tonight based on 26¼ minus an inch. So we're going to say it's 25¼ instead of the full 28. That's the leg. This is a sample leg. It's going to be shorter, but that's okay for demonstration and for testing. And then we get everything all worked out. Of course, we will come back and make this out of, something like walnut or a nice hardwood. Right. So let's go ahead and take a look at the drawing right here. And I apologize. This is that mouse that's way over responsive. It's going to drive me crazy.
Go into Windows settings and change the sensitivity of your mouse.
Yeah, I'll have to do that. I'm not going to waste the time on it right now, but I'll do that before we do this again. Okay. So here's what you remember in class number 2. We machined from 0 down to 4.5. This end right here. Machined it square, and we cut the mortise. So tonight we're gonna work from this point down to the very end. So we're going to turn it round, we're going to cut this first section. We're going to cut a tapered section, and then we're going to cut these 2 beads, and then we're going to do a lamb's tongue. So that's the process for tonight. Let's go ahead and open up. It looks like I don't have it open right now. Let's go ahead and open up CCAM Pro. All right, and we go into projects. It's the display table. And if we look through here, there's the joinery that we did last week. Here's the leg. We've done the multi-sided square and cut the mortise. So let's go ahead and add the next section. So we'll just, once we're highlighted on the blank, we can click up here on Manage Toolpaths, and we can add a toolpath. So this one's going to be turning round. And to be honest with you, you and I are kind of learning and testing this together. So as we go through it, if we find surprises, we'll make notes and pass it along, see if we need to make any corrections or improve the system at all. But Mike's done a heck of a job on setting this up. And you can see this one right here right now says that we're going to recommend this cutter because it's flat on the bottom, where the industry standard has a 1 degree taper. So that's the cutter we're going to use. It's under surface planing, and it's the 1.25" cutter right here. And we'll select that. And this was, last time we used it, it was our number 1, and that's what's in the tool database. So we'll go ahead and use the default out of the tool database. And it's not turned around. So what we're going to do is we're going to start right here, and let's open up the drawing and take a look. So we're going to start at 4.5, and we're going to cut down, what did I say, 25.25? Let me double check that real quick. Right, we're going to start at 4.5, and we're going to get down 25.25. So the starting position, 4.5. And then we're going to turn this to 1.5. And then we're going to end this at 25.25, 25.25. Our rough pass step over, 0.375. Our rough pass feed rate is 500. And I could even push it up higher than this. While we're cutting, we'll probably just increase the feed rate on the fly as we cut. We'll leave it for 500 right now, so that if you use this, it won't be moving too fast and you'll feel more comfortable. Once you get used to it, you'll be able to push those numbers up. Rough pass depth. Okay, I'm going to make this 0.375. We can hog off the material pretty fast. Pass depth, yes. Finish pass step over is going to be 1/8 of an inch, and we're at 800 inches a minute. And this one we're going to set at 0.125 for the depth of the final pass. All right, now we've got our plunge depth. In fact, if we set that deep enough, we might be able to do this all in one pass, but we'll leave it as a rough pass and a finish pass. Plunge depth per rotation, 1/8 of an inch is good. I'm going to speed up our turning plunge feed rate. So this is when it's plunging and rotating, cutting the end of it. So there is no x-axis involved. It's just, it is at a fixed x-axis. It's just getting it down to the diameter. I'm going to set that at 150. And our tool clearance, 1/8 of an inch, that's good. And now it's asking if this is tapered. Now this is different than the original conversational cam. So in conversational cam, originally you might turn the whole thing around to 1.5 inches, and then you would create a separate tool path that would do the tapered section from wherever you're going to start to taper down to the end. And it's 2 separate tool paths. But the way Mike set it up here is it's going to cut. It's going to turn it around, and it'll cut in both directions to optimize the cut. And then we're going to add the taper in here as well. So we're going to do both the turning around and the taper in one toolpath. So this is the taper starting position. And if we look at our drawing, we're going to start tapering down here about 7.5 inches. Okay, so we'll put that here, 7.5. And the diameter is the same. It's 1.5. That's what we turned it down to. Okay, and then the ending position is going to be 25.25. We'll go all the way to the end. And the diameter down here, we're going to start at 0.75. We might adjust that later, but this is just our test. We'll see if that looks good to us, okay? Taper start cutting position. All right. So you can look at the help screen that Mike's put together on this, and it'll kind of explain a lot of the details here. But in essence, what's happening here is that you can say it's tapering from point A to point B. Let me bring that drawing back up and kind of illustrate. You could say the taper is from this point down to this point, but you might only be cutting the taper from somewhere out here to somewhere here. So you can define the actual overall taper, but only cut a certain section. What's cool about this is that you can have this taper set up for one taper and cut down here and then cut a bead or something on here and then finish the taper. So this is a very powerful concept that Mike's put together in here, but let me show you how to use it. Okay, so we've got, yes.
Is the ending taper position actually 25.5 or does it go down to 28?
It's 25.5. And the reason being is because when I measured this particular blank, this isn't the real part. This is just a trial. And so because I measured this part and it's not a full 29 inches long, so we can cut 28, it's only 26.25. So I'm not cheating a little bit. I'm using the numbers off the part, not off the drawing. We'll come back, and when we make the real thing, we'll use decent hardwood, and we will make it 28 inches, and the part will be cut 29 inches long. Does that make sense?
Thanks. Yeah.
Okay. Now here's where he asks, okay, where's the start cutting of the taper position? So over that overall taper, do you want to start right at the very beginning, or do you want to start further down at a different location? So if we look at our drawing right here, we've started right here at 7.5, and we're going to start the cutting the taper right there as well. Okay. So this is going to be the same, 7.5. And then taper, the end cut is going to be the 25.25. So it'll cut all the way to the end. Again, so this is pretty awesome, because what it's going to do is it's going to turn it straight around. You'll see this in a minute when we start cutting. Then it's going to have us adjust the bed for the taper, and it's going to cut the taper. And then it's going to have us put the bed back to the level. And at that point, it'll pick up the cut, and it'll cut the next process, which is going to be, let me finish and save this one. We got the turning around. So let's go add the next process, which will be a turning, but it's going to be based on tool profiles.
Tracy, should your length be 24.25? You have an inch that's up there by the chuck, and your
right. Yeah, you're absolutely correct in theory, but here's the difference. So on this drawing here, the blank was a full 29 inches long. That's what we actually drew it as, but I don't have a 29-inch blank. My blank is 26.25. So I said, okay, well, let's burn this inch at the left-hand side. So we're going to start 0 here. And so we'll really only have 25.25 inches of length to cut. So the leg's going to be, yeah.
I'm sorry. I thought your whole blank was 25.25, but you say it's,
oh yeah, it's 26.25. Right. Okay. All right. Now this one is fairly simple. It's just a few things to enter in, and we used the classic spiral. If we went back and look at the drawing, it's the not the classic plunge, I'm sorry, the classic spiral, and we're using the 1.5 inches in diameter. So we'll go ahead and select this one. And in our original tool pass, tool number 1 was the surface planing bit for machining it square, and we also used it to turn around. Tool number 2, as you remember, was the cutting the mortise on 2 sides. So we're going to make this one tool number 3, and that's actually what it was last used as. So you can either click on last used, the original, or you can put a new number in here, 3, 4, 5, whatever you want to use. We're going to put 3 in here, and I'm going to assign number 3 to that position. And then our section diameter is 1.5. That's what we turned that down to. So that first straight section is at 1.5 inches in diameter. And now we need to see where we're going to cut this in the x-axis. So I'll zoom in a little bit here, maybe not too much. All right, so the center of the cut is right here, and that's at 5.25, and then the second one right here is 6.75. So we'll put 5.25 in here, and we're going to use a comma and put 6.75. Right, so that's another feature that Mike's built into this, is that you can cut multiple cuts using the router bit profile simply by separating by a comma, just like we did on the 2 sides with the mortises. And this is asking, we're going to use profile height. Now, if you're not sure what that means, it explains it right here. The profile height is the parameter of the tool table that measures the cutting depth of the actual profile. So from the tip of the cutter up to the shoulder, and it's already in the tool profile, so you don't need to know it or enter it. You do not have to enter in how deep to cut. You just say, yeah, use the profile height. Simplifies things a great deal. Plunge depth per rotation, 1/8 inch is good. We'll climb mill on the left-hand side. That's excellent. Feed rate, I'm going to speed this up a little bit, maybe 150 inches a minute. We could probably go even faster, but we can play with it. We'll go there. Clearance is going to be 1/8 of an inch. And this section, if we go back and look at the drawing, is not tapered. Okay, so we didn't taper this first section right here from 4.5 to 7.5. We left that straight, and we started the taper at this section and went down. Okay, so that's why the taper is no.
Tracy,
So
can
now
you explain, can you maybe elaborate on the mill side, the left side?
Oh yeah, okay, absolutely. Let me pull up this drawing real quickly. Now, this is the router bit profile right here. All right, so when we're looking at the part, headstock here is at this end, but when we're looking at it from the front of the machine, which remember is the I'm at the end of the machine. The front is the other side. Then you're looking at the blank like this. So the left is this side, and the right is this side of the cutter. Okay. So one thing to keep in mind is if anytime that you can climb mill, you're going to produce less tear out. You're going to minimize your tear out. The conventional milling or undercutting is cutting, and it's tearing the grain out in front of it. So it can rip things up. In this case, it may not matter at all because we're going to do a lamb's tongue, although right here where the lamb's tongue meets this edge, that could possibly create a problem. So we're going to climb mill on this first cut on the left, and we're also going to climb mill on the second cut on the right because this all disappears. We don't have any shoulder here that we're messing with. So I left them both as just the left, and it's good to go.
Thanks.
That makes sense?
Yeah.
All right. All right, let's go back in. So the last thing, I'll go back to the drawing. The last thing here, we've machined it round the full length. We've cut the taper from 7.5 down, and we've cut these profiles to form this bead. The last thing is the lamb's tongue right here. So we'll go back in here, and I'm going to say manage our tool paths, and it's going to be turning based on a tool profile. And this may not be a bad idea to actually create a lamb's tongue tool path so that you don't have to think about it. But we just use a standard tool profile, and I'll show you how we'll accomplish this. Okay, so the cutter that we're going to use, I'll click on that, and we're going to go all the way to the bottom to V bits, and we're going to use a 90-degree cutter. I have is actually not 1 inch in diameter, but that's typically what I would use. And so that's what I'm going to put in here, and we'll go ahead and select that. And the last cutter that was used was 4. So we can go ahead and just say, yeah, that's the tool we want. So 1 is the surface planing bit, 2 is the end mill, 3 is the classic spiral, and 4 is the V-bit. It's the last one. And if we added another bit, for example, I would like to play with this. I didn't have time to experiment with this, but I want to cut some flutes in the tapered section, and Mike's developed some really cool tools inside that. So we'll come back to experiment with that as well, but we're just going to use 4. And when we cut flutes, we might use tool number 5. So we'll go ahead and use 4 for now. Okay, the section diameter here is 1.5. So let me go back to the drawings to explain this. Okay, so this has all been turned to 1.5, and this square is 1.5. So that's the diameter of the stock. All right. Now let's go into the x-axis position. And if we take a look here, it's going to be, the center of the bit's going to be right here at 4.5 inches, right at the end of the square. So we'll put in the 4.5. Now it's asking, do we want to use the profile height? And the answer is no, because if we did, your V-bit would start here, and then it would cut down into here, whatever the profile height of the V-bit is. All right. And at this point, I don't really care, but we're going to say, no, do not use the profile height. It's asking, well, what is the cut depth? And I noticed on one thing, I haven't had a chance to test this, and I'll have to do more testing, but when I was turning round and it was already round and you said, turn it to the same diameter, it didn't turn it because it was already there. So it didn't produce any code to turn round, which caught me by surprise, but it makes sense. If it's already round to that diameter, there's no need to cut it again. So even though you put it in, it just skips the code. All right. It doesn't produce any G code to do that. So it may do the same thing here. So what I'm going to do is I'm going to set a cut depth. And if Mike's here, Mike, if you're here, you might want to jump in and correct me if I'm wrong. But if I put 0, it may not do anything, but I'm going to put 0.001. Okay. So that's 1/1000th of an inch. So it's going to force it to cut, but it's only going to be 1/1000th of an inch deep. I'm afraid if I left 0, it wouldn't cut. And I'll have to test that to let you know if that's true or not. But right now we're going to set it for 1/1000th of an inch. Plunge depth per rotation, that's fine. Climb mill side. Okay, this is the same thing. Our cutter is right here, the V-bit, and we're going to climb on the left side because we don't want to tear out this grain right here from the square against that shoulder. So we're going to leave the climb mill side on the left. And our feed rate, I'm going to push it up again to 150 inches a minute. Our Z clearance, an eighth of an inch, and our taper is no. Okay, it's just the bed's all level and ready to go. So finish and save that. So now what I have here is the multi-sided. I've got a mortise. I've got turning round. I've got turning with the tool profile to cut the beads, and then I've got the lamb's tongue that we're going to cut right here. And if we generate all this G code, of course, it'll cut everything. Now, in the past, we tested the first section, surface planing and the mortises, and but I don't have that piece. I've got a brand new part. So we're going to recut everything while we do this part. The one thing I want to show you here is after it machines square and does the indexing mortising, then it does the turning round, and it has a pause right here. This is an M0. This will pause the program, and then you'll be able to see in the line it says set the bed to 1.2 degrees, which is the way we used to do it, which is not very accurate. Or you have the option of 19.4 turns of the handle, which is the most accurate, or you have 1.94 inches. That's the elevation you're going to raise. So you can use any of these 3 measurements to set the angle, but the most accurate is the number of turns. Now, we've talked about this right here, and I took a picture I want to show you. You won't be able to see this in the video because I don't have a camera on it, but when I adjust the bed, I'm going to be turning this handle that you have on the end of your stock. And you'll notice that now there is a decal on here, and it has the pointer right here, and it tells you which direction. Counterclockwise will lift the bed, clockwise will lower the bed, and then it's broken into 10 locations or calibrations here. each turn of this is 10 threads per inch. So each turn of this, or each tick, each number here is only about 10 thousandths of an inch. Okay. Because one full turn is 100 thousandths of an inch. So this makes it very, very accurate. And you can see right down here at the bottom, you probably noticed there's a little knob down here that you can lock the bed in position. There's one on each side of the bed. Anyway, I'm going to loosen this. I'm going to turn this 19.7 turns in counterclockwise. So it'll go around 19 turns, come back to the 7 right here, and I'll lock it down. We'll make the cut. And then when I return it, I'll go back the 0.7 to 0, and then I'll lower it 19 turns and lock it back in position. Now, one of the things that I will do, because I want to take up any backlash in the screw, is that when I'm lowering it, I'm going to turn it back 19.7 turns, so it goes back to 0. I'm going to go beyond that about 1 turn, or at least a half a turn, so that it goes beyond the point, and then I'm going to raise it back up, and that takes any backlash out of the system, and so it's raising back up to the 0, and that'll set it back to level. Okay, so I just wanted to kind of give you a heads up. That's how it's going to work. You won't be able to see it real well in the video because I don't have a camera on it, but that's how it's going to work. All right, so let's do this. Let's go ahead and save our G code.
Tracy?
And, yeah.
To back up just a little bit, when you were talking about that taper and you like the way you can start and stop it where you want, if you wanted to put, you said something about maybe putting a bead, let's say you wanted to put a bead an inch up from the bottom, and then you could start the taper again. Would you use that comma, put your start, put your, at one point, and then do a comma, do another start? Or would you have to do a separate tool path to separate that one area you wanted that bead?
I haven't had a chance to test that. I need to talk to Mike about that and see if that's how he's done it. He typically will build it so you can do multiple cuts in it, but I'm not sure on this one. So I'm going to have to find out the accurate information before
In this case, you would have to put a separate process in.
Oh, okay. Thanks, Mike. So the way it's going to work then is, let's say that our taper is from this point, 7.5 down to 25.25, or in this case, 28, according to the drawing here. But you're only going to cut from this 7.5 down to a location here, maybe 20 inches. And then you're going to come back and make a second profile. You'd still use the taper as this position, 7.5 at 1.5, and down here, the ending. But you would say start it past the bead and end it here at this end. And then you could come back and machine the bead or the detail in that section that's left. But it would be two tool paths. Great. All right. Hey, thanks, Mike. All right, let's go back in here then, and we're going to save our G code. And we're going to call this the display table leg. And I'm going to put on here 25 inches, because I know this isn't the right one, but it's the material I had. And so I'm putting that in this, so I know it's not the proper program. If I go to run, the real wood, I'll have to create one that's the proper dimensions. All right. And then we'll go ahead and eject this. Okay, so I'm going to insert right here, and I've already homed the machine, and I've clicked on the turning workstation. And so I do not have to do a smart tool setup because we're turning. And I've also created one offset here. I have 5 offsets in the turning. The first one is called 4-jaw chuck, and it's right at the end of the jaws of the 4-jaw chuck, but we didn't like that. So the second one I called 4-jaw chuck 1 inch, just to let me know that this is going to be 1 inch from the end of the wood. Okay, so so if we look at our drawing again right here, I have set the x-axis right here at 1 inch. Okay. Oh, I need to. Okay, sorry. This is what happens when you got a rookie at the wheel here. Okay, so again, from the end of the wood, not the jaws of the chuck, but from the end of the wood, I said 1 inch. So my x-axis in this work offset is set right here, not here at the end of this. Okay, now that brings up one other issue that you need to be aware of in order to get tapers correct. I'm going to go back into Conversational Cam Pro. And if we go to our database for the machine database, I'm using the Gen 3 of the 4x8 auto tool change. And right down here, you have some values for the pivot height, 10.25. You have the pivot lift height, 8.526. You have the pivot length start. And you notice that my number right here is 1.9 inches. Now, probably the best way to do this, because this is actually measured for this 1 inch offset. Remember, when you change the starting point of the part, then this value is going to change, which will affect your calculations. Okay, so what I did is I took my laser and I pointed to the pivot point, and then I went back to my, actually I started at my X0 on my turning blank, and then I went forward to the center of the pivot bolt with my laser, and it was 1.9 inches. And so I changed the value that was in here to 1.9. So this is one thing that you'll want to check. And we have on our website, we do have a video on setting up these values for your machine. And you'll want to double check these values to make sure they're accurate. Otherwise, your tapering will not come out correctly. Okay. So I did 1.9. Now, in reality, what I should do is I should probably change the name of this guy up here to 1 inch and say save new. Okay, so now you notice that I have a 4x8 Gen 1 with 1 inch from the 4-jaw, and I could rename this one 4-jaw chuck or something, you know, so that way, if I'm not using the 4-jaw chuck, I could go back and use this one with the original values. If I am using the 4-jaw chuck, I simply come up and use this one and generate all the code. Okay, so this is one way to create basically a post processor for tapering that is determined by where your x-axis starting point is. Okay. All right, let's go ahead, and we already saved that code and I've already loaded it. So I'm going to stop sharing here.
Once you've made those changes, do you have to redo the G code? Is it going to change something in that?
Yeah, you want to set those up first. And so as you generate the code, if you've generated code and you make those changes, you want to generate the code again. And all you have to do is click the generate code button, and it will recalculate everything based on those numbers. Okay. Again, the X or the offset is, I did change that to the 4-jaw chuck for 1 inch. But I don't have to do anything with Smart Tool. I do have to make sure Smart Tool is on so that it'll set it to the center of the blank correctly. And now at this point, we're ready to put the blank in. And I've already placed, you can't really see them, they're out of focus down there, but I've already put the 4 cutters in the tool order. If you're using a manual tool change machine, you really don't have to worry about the order, because it's going to tell you what cutter. It's going to give you a number, but it's also going to tell you which cutter to use. You just put it in with your wrenches and go ahead and cut. But in this one, it's going to pick it up out of the auto tool change. So let me go ahead and set up the part, and then we will go ahead and cut. What I'm going to do here real quickly is I'm going to mark the center of the blank. I'm going to use an awl to do this, and then I'll use that in the tailstock end. Of course, the headstock end is the 4-jaw chuck, so it will simply center the part for us automatically. Now you'll notice that I didn't have to get extremely accurate there because we're tapering that end. It's not critical that it's absolutely centered. Closer to the center, the better, but I just eyeballed it. Now I'm going to go ahead and clamp that in place, and then I'll show you how we square it. Now, I simply, drove the tailstock in, and then I was wiggling it a little at a time until it didn't chatter anymore. And then I locked it down that place, and I rotated the handle, to ratchet so I can back it off, and then rotate the handle so it's at the bottom so it doesn't vibrate and, move while we're cutting. Now, this particular tailstock center, you can see, is just a big tapered cone. It's not the best, but it works. What can happen here is if you're doing a tremendous amount of turning, especially in a softwood like pine, is that it can kind of open up the material. So a better option is a revolving center that has a ring around the point. So the point centers it, but you can drive it in until the ring is touching, and that will not let it go in any farther at all. This one right here, I could keep tightening it and just keep driving that into it because it's soft wood. But the other type, and that's actually what we ship now with the machines. Originally, we shipped these, but you may, if you have one of these, I use it all the time, but you may want to exchange it for one with a ring on it so that it can't drive in too far. The other thing you want to watch is that you don't want to really drive it in extremely hard, because you can kind of buckle it'll tend to try to lift the wood at the tailstock end a little bit. You just need to drive it in enough to take out any vibration, and then tighten down the headstock. All right, now what I'm going to do next is, that part's obviously not ready to start cutting. The code, let me double check. I'm sure this does this, but when it starts, it sets the A-axis. Yeah, it sets the A-axis to 0. So you don't have to set it before you start running the part. Wherever you have the part set, it's going to lock it at 0. So we just want to square it first, and then we'll go ahead and run the program. Okay, so what I'm going to do is I'm just going to put a blank across here. I'm going to put it in step jog, but we're doing in degrees now. So I'm going to set it for 1.0. So every time I click it, it'll go 1 degree. I can change that and make it a half a degree or whatever I want. But if it's 10 thousandths of a degree, you will not see anything move, and it'll take forever. So we're going to set it to 1.
Tracy, is there a way to do degrees in Mach 3, or is that just delta?
In Mach 3, there's not. Well, technically, you probably could. You have the settings in the config, the general config of Mach 3, where you can actually assign the steps, the digit. And so you could set 1 to 1 inch or to 1 degree, but it would be 1 inch. It wouldn't read that on the screen. It'll still read 0.1, 0.01, and 0.001. So it won't read accurately, but you could kind of fake it out and tell it to move that way. What I typically do in Mach 3 is I simply slow my rotation way down, the percentage of the feed rate. And then I can just, bump it normally, but it's going to rotate very, very slowly. I might put it at 2% or something. So it's barely rotating instead of step jogging. But in here, I can just rotate it. Now it's hard to see right there, but well, you can kind of see that part is pretty flat now. And I'm measuring it against the tailstock. You can actually measure against the table, kind of compare it. And so this looks good. And I'm going to resurface the material so it doesn't have to be perfect. You just want it close, and that's going to work just fine. So I've got it just so it's close. Now you could eyeball it without that piece on there. This just kind of illustrates, makes it easier to see. So I set that part up level with the tailstock or with the table. That's all it is.
Tracy, am I correct that every time you chuck in that 4-jaw chuck, the jaws are always going to load the stock in exactly the same place? In other words, if you were to zero that out right now, get it perfectly square to the table and all that, then do one of your turning offsets, set it to 0. Every time you chuck something in that 4-jaw chuck and you hit, or you go back to your 0, it should be square to the bed, correct?
Theoretically, you are correct, Alvin. Here's the issue. When you home your machine, you're homing X, Y, and Z, so it finds the center or at the end, the home position for that. But it doesn't find A, it just sets it to 0, wherever it's at, okay? So if you ended on A, 0, or 90-degree increments of it, then when you end it and start it back up, it will be set back up. But if you've rotated it and it's angled, it's not level, you turn it off, turn it back on, you'll have to level it back off again. So, if you end up level, turn it off, turn it back on, you're right. It'll be exactly perfect. It's just that if you turn it off when it's not, then you will have to find it.
There's no way to go to A0, right? There's no like A0 button like your XY0.
Well, you can do, now I don't have a button for it, but you can use the manual data input. So right now my A-axis is reading 17,210.07 degrees, right? So if I said go to 0 now, that thing would unwind 17,000 degrees, okay? So typically we wouldn't do something like that. I could come up here and just click on the A-axis and 0 it. And now if I rotate it a little bit, let me take it off step jog. Okay, so I rotated a couple of rotations. Now, if I use the MDI, which is the manual data input, and I simply put A0 here, and then I push on the execute. Okay, that's out of focus on that view. I'm sorry. But I'll do it again. If you rotate it, whatever, and then execute that MDI, it'll take it back to 0 degrees. Okay, so there is a way to do it with the manual data input.
So if I know I've got multiple turnings to do and I have to do them on different days, the machine's going to be shut down. All I need to do is 0 that before I shut the machine down. I'm good to go the next day.
Yeah, that's the way to do it. Now, one of the things that, and I'll need to get with Mike, but one of the things I was changing in the original conversational cam as I was updating the toolpath was I wanted everything to rotate in either 90-degree elements or multiples of 360 degrees. So for example, if you were turning around and it would say, I'm turning from point A to point B, turning from point A to point B, and I'm going to have a step over, then it'll calculate how many degrees it has to rotate. It may not be a multiple of 360. So what we were doing is calculating where it's at, calculating the difference and rotating it to that point. So we had it back to, the starting point, 0. And so it might be wound up to, some 30,000 degrees or something crazy, but it would be a multiple of 360. So if you simply started the program, it'll reset it to 0 right there and do the same things again. Okay, yeah, even if it's
in all the turning toolpaths, I go back to A0 by the time I finish the process.
So you drive it back to A0, Mike?
Well, I drive it to a multiple of 360 and then 0 the A-axis.
Oh, same way, same thing then. Okay, perfect. All right, so there you go. anything that you're doing here, if you start in 0, should end up at 0, and then you can turn it off, turn it back on again, and you'll be good to go. That's perfect. All right, let's go ahead and set it up maybe this way. I'll start here so you can kind of see how it runs. Now, I already have tool number 1 in there, so it's not going to put a tool away or pick up a tool or anything like that. So I'm just simply going to press the cycle start button. It'll come up, touch Smart Tool, and then should, if everything goes right, if I program it correctly, we should be good to go.
Don't you just hate it when it does that?
Yes, I do hate it when it does that. Okay, I got it. Wow. I'm getting an error number 1. And to be honest with you, I don't even know what that is. Let me look it up here real quickly.
Now you know how we feel.
Like I say, we're learning this together. So I apologize. Let me just look it up here real quickly.
Did you reference the machine before starting the class?
I'll double check, but I'm sure it is. Oh, that's interesting. Okay. Wow. Error number 1 is file does not exist. So let me open this file. Oh, I know why. Okay, I just figured out what I did wrong. I put the file in here, but I already had a file in, and that file's gone, and I did not reload this new file. So I just have to come in and go to my flash drive and select that file. Okay, now this will work. It better work. All right, here we go. Yay. Okay, I apologize. I can't hear you when it's cutting, so I could hear some background noise, but it's going to now change the cutter and come up, cut those tenons.
We solved our own problem, Tracy.
You got it? Okay. So we do have a little ding in there, but again, prototyping, we're okay. Okay, so that's what we've already done. You've seen that before. Now it's going to pick up and do the rounding. And then that's where we'll have to adjust the bed once it's turned around.
Tracy, is there a way to make it group the processes so that it's more efficient and doesn't go back to a cutter a second time?
Yes. Okay, so the program's actually paused, and on the screen it says set the bed 19.4 rotations. Okay. So I'm going to make the adjustment 19.4. I'm going to move this back a little bit so you'll be able to see. Actually, I can't move it. I can't move it while it's paused. It's holding the program, so I have no control. So let me adjust this other camera so maybe you can see how that adjustment. You can see the tip of the handle there. I'll go make the adjustment. And then at this point, again, it's just paused. Like in the program, it's actually got a screen here that flashes saying I'm in an M0, so you know that it's paused intentionally, waiting for you. And then you just press the cycle start button again.
Tracy, when it tapers, does it taper in both directions like it does turning around?
No, I believe it just tapers in one direction from the headstock to the tailstock.
Tracy, what's the offset from the center on, or the zero on the Y direction? It looks like it's cutting off to the outside.
Okay, I apologize. I can't hear. As soon as it's finished, then I'll get back to it.
I'll ask after you're done.
Okay, now it's flashing at me saying I'm paused, waiting for you. And it says set the bed to 0 degrees. So I need to go back to 19.4. And you'll notice I'll go past it and then back up to take out any backlash. And I'll move the camera so you can see it again. Okay, what's the question?
I thought that the taper would start and run uniformly down the leg. But it appears that it didn't. It started later, further on down the leg.
Yeah, that's what I've noticed too. It should start just 3 inches down from the flat, and it looks like it's starting at probably about 5 inches. So what I need to do is I need to go back and double check my calculations for my bed settings. You know, when I went into the machine, I said, you got to check these values. I'll go back and check
Tracy?
mine and see. Yeah.
What I do there is that I calculate what is the maximum depth of cut by the time I reach the end. Then I back up to the x-axis to give me that cut on that taper. You see what I'm saying?
Right.
So if the depth of cut, whatever the maximum depth of cut is, say that it's 1/8 of an inch, I back it up to the X position that would give me 1/8 of an inch by the time I reach the end of the taper.
Oh, I see. Okay. Yeah, I'll have to, Mike, I'll get with you. I want to break into the program and look at the calculations and everything. The one thing I noticed on the original one, what I did was I calculated, how many passes it would take. In this case, we did 2. It was a rough pass and a finished pass. And so on my rough pass, I wouldn't start back at the very beginning. I would calculate, where it would start in the middle and do that. And it didn't look like it did that in this project. So I'll need to get with you and we'll go over the math and see if we need to make any updates or changes. But that's the basic.
Well,
Tracy, it didn't do that because you told it not to do it until it got to the 7.5 because it got those 2 classic spirals that needs to go, and they weren't tapered.
Correct. So, well, what I'm saying, let me look back at this part. So, you should start the taper about there. And it looks like it started down just a little bit. So that's, that's the calculation I need to double check my numbers and we'll check the program. Now, and it lift that first part, like you said, straight, because those are where we're going to cut the 2 tool pass with the router bit, which we're going to do next. And then we'll come back and do the lamp stung. So right now the program is simply paused right here. And as soon as I hit cycle start, now that I've made the adjustment back to 0, it'll finish cutting this part. So we'll go ahead and finish the part and then come back and go over any questions.
What's the diameter of the tailstock end?
Right now, you mean if I were to measure it?
Yes, sir.
It's oversized by about 1/10 of an inch, which would indicate that that's probably my calculations on my machine, but I'll need to double check that and find out if it's me or if it's possibly the program. We'll look at it that way. Yeah, it's a pretty complex set of calculations to figure out exactly how much the bed adjusts so that you get the proper diameters at starting and ending points. But we'll check it out, come back and do a recap on it. Like I say, we're kind of learning together here, so bear with me. All right, well, we're ready to go now. We'll go ahead and just press the play. I just realized what the issue is. I know exactly what's going on, and it's not Mike's calculations, it's mine. So when this finishes off, I'll come back and explain it and show you how to fix it. Okay, it's simply going to change cutters to make this next cut. Let me explain. If we go look at my settings, I'll let it finish and then we'll go ahead and explain it. Okay, so there's the part, and it dawned on me what I had done to screw this up. 2 things I've done to screw this up. Okay, so let me share my screen and I'll show you. If we go into the settings, okay, so I'm back in the machine database. I go to databases, machines database here, and I'm looking at this one right here. This says a pivot start point is 1.9 inches. In reality, the pivot point is ahead of the stock. So this should be a negative 1.9. And now it's going to make the calculations correctly. So Mike's calculations are correct, but mine are off by 4 inches, which makes a huge difference in where it starts and where it ends. So if we looked at the, stop sharing here real quickly. Again, we look, it should have started tapering right here, and it started down here, probably 4 inches, which is that difference that I had, 3.8 inches rather, because my pivot point, instead of being back here, 1.9 inches, is actually out here in front, 1.9 inches. And that's what
Share your
pushed everything.
screen.
Oh, I'm not sharing? Okay,
you
sorry
got
about
the
that. Okay. Oh yeah, I don't want to share here. Okay, I'm sorry. You can see the machine right now with the part, right?
Right.
All right. Okay, so again, can you see my mouse on the screen?
No,
Oh, you
No.
can't.
no.
Oh, that's what's wrong. Okay, well, let me go. I'll share my screen then and show you the.
Point with your,
Use your
point with
finger
your
on the
pencil.
part.
Yeah, I'll do it with the drawing so you can see it. Okay, so I'll zoom in here a little bit. Here's my X0, and I programmed it as this is a positive number, so the pivot point was back here. Can you see my mouse here on this screen?
Yes.
Yes. Yes.
Okay, so I said the pivot point was back here, 1.9 inches. In reality, the pivot point is up here, 1.9 inches. It's down below, but it's out in front. So this is a negative 1.9, not a positive 1.9. So that's why it pushed everything down. That's 3.8 inches and cut to a larger diameter, because it had just shifted everything down because I had those starting positions incorrectly. Does that make sense?
Yes. Yes, it does.
Yeah, okay.
How is
So-
it a negative to the right of the chuck?
Say that again.
How does it become a negative if it's to the right of the chuck?
Okay, so here we're looking at the machine. And from here, it's actually left of the chuck. Okay,
We're
because
looking-
okay. So the starting point is out about where the mortise is starting. That's actually about the pivot point. So from there, instead of moving to the left, which would be a positive, we're going to the right, which is really a negative. Okay, so it's from the pivot point all the way, everything to the left in this picture you're seeing here, everything to the left from the pivot point is positive, everything to the right is negative. I had a positive instead of a negative number in there, and that's what pushed everything down and screwed everything up.
That sounds backwards to me, but okay.
Yeah, backwards for me too. It doesn't make sense.
Are you talking in the X?
Let me-
direction or-
Yeah, let me share my screen again, and I'll maybe draw something up and see if this will help you at all. Okay, so
You have that drawing handy, Tracy, the pivot point, how you measure everything, or is it drawing?
let me look on our website here.
It seems backwards because when you go that direction on the horizontal table, you're going plus numbers.
Down further.
Down further. I can't remember how far back we did this.
I just looked at that not long ago. It's an early one, how to set up that act.
Oh yeah, it's way back. Wow, I didn't realize it was that far
And
back.
now you're getting there.
There it is.
Machine settings. Okay, let's look at the machines settings PDF. View the machine settings. I'm going to download this PDF. We'll take a look at it. Okay. Here you go. This is the machine, of course, looking from the back side. So here's the pivot point. Can you see my mouse on this screen here?
Yes.
Yes.
Okay, so this is the pivot point. And this is on a Maverick 3x5. And you can see that, let me see if I can zoom in here. So from this point, everything is measured this direction. So my distance right here is to the left. So this is a positive number because again, 0, everything that's going this direction is positive. Everything going to the right is negative. And since my pivot point is actually not back here, but it's actually up here farther, then that negative from this point here, it's going back. That's a negative starting point, not a positive starting point. Does this drawing help? Does this make sense?
Yes.
You're not
Okay.
saying the pivot point is a negative. You're saying the starting point is a negative from the pivot point.
You got it. That's right. Everything's measured from the pivot point. And again, on the 3x5, it's a positive number. I accidentally, and so if you've got the system in a 4x8, you go and look, it's going to have a positive number because I put it in backwards. So you're going to have to change that number to a negative. I just realized, and I'll have to make an update here to all of our files. Okay. All right.
When you cut the taper, you seem to offset in the Y in a positive direction. So you went to one side. Is that correct? Is that a step over of a certain amount that CCAM calculated? So your bit didn't
You
come
say
down.
when it starts turning it around, it moves the Y. Is that what you're asking?
Yeah, both on
Yeah.
the turning and also on the taper.
Yeah. So that's exactly that is exactly correct. Let me go back into a drawing here, and I'll show you. If we look at the end view of the part, let's say this is the turning around right here.
Yep.
Okay. And your router bit is something like that.
Correct.
Okay. So when we first start cutting, we put it right centered over the part like so.
Y0, yeah.
Yeah, so that's at 0. Then what we do is when we go to cut along the length, if it's sitting in the center like this, maybe I can do it this way too. If you're looking from the top view, and let's say your router bit's right here, and it's zoom in here a little bit.
So you would only be cutting with the center of the bit versus cutting with the
Right.
side of the bit.
So you can see when it is centered down the center line like this, it's only cutting because it's round. It's only cutting here at the left and right here at the right, and it's cutting cross grain, so it gives more marks. So what we do is we take this guy and we push it over here, so it's just barely overlapping about 1/8 of an inch of the center line. So now that it's cutting this direction, and we're actually climb milling that cut along the length. That's why it moves over when we start moving along the x-axis. So both ends are going to be centered like so, but before it starts moving down, it's going to, if I can get it to move, it's going to move over.
In essence, it's
like
a
that.
it's a small step over, but it's cutting when it's all the way down. It makes sense to me. Okay.
Yeah. And again, what we're trying to accomplish here is that we're trying to minimize tear out. So we're climb milling everything, and we want to cut with grain whenever possible. And that's why we overset. It solves those two issues.
So Tracy, I didn't notice, but when it comes back the other direction, turning red, does it rotate counterclockwise then, or the other direction?
Yeah, it'll switch to the other side. Yeah, when it's cutting back from the tailstock to the headstock, it moves to the opposite side, so it does it. My battery's going to die. I'm going to switch batteries. Hold on.
Hey, Tracy, I got a question.
You bet.
On that file with that setting for the Maverick 3x5 on the pivot points, those figures, those numbers, very little. Barely you can read those numbers.
Oh, right. In this PDF that I was showing you.
Yes, sir.
The drawing. All right. So let me show you one other thing. I'm going to share my screen again here real quickly and show you one other possibility. All right. So we're going to go to here. Now, this is the PDF. You can download from our website also machine settings, the CRV file. And so if you do that, you can open this up in Aspire or CCAM Pro. Evaluation license will expire in 5 days. And so you can now, oh, I thought I took the dimensions in here. Maybe I did. Handle bottom, handle heart dimensions. There we go. Okay, so they're in layers, so you can turn them on. So in this, you can zoom in and see the numbers real clearly. The PDF is not so much. So download this file, the CRV file, and then you'll be able to see. And you'll want to double check the reason that video shows you how to measure from here to here, along the x-axis, how to measure from here up to the center here in the y-axis, and all the different dimensions. So watch that video and then double check your values so you get them entered in correctly. And again, in the 3x5, you'll notice the pivot point is to the right of the part. So the part is a positive, and on the 4x8, as we now know, it's a negative because the part is behind the pivot point. So
Yes, sir. Appreciate it. Thank you.
okay, no problem.
Hey, Tracy, you said that you had a error code. You looked it up there. Do you have a listing of the error codes for the Delta? Because I've gotten a few in the past and I had no clue what they were.
Okay, yeah, I did post the error codes for soft limits because that's generally what it is. I'll post the other one too. And again, we put it on our website. Let me share my screen again real quickly. Go back into our website. Under training customer support files, I believe it's in here. Let me double check. Maintenance schedule router bits.
You gotta go to the Maverick 4x8 files.
Oh, you're right. So Maverick 4x8. Spire, Maverick, Gemini. No, maybe not.
That'd be something that'd be nice to stick into CCAM so that it'd be available to everybody right off.
Yes.
Yeah, okay. Pretty sure I had it in here, but maybe I don't. Okay, I'll post it. Oh, here it is right here. Here's the Delta soft limit error codes. So this one I did post, but it's only the soft limits. I will post the entire list so that, if you read a code like this on the air, mine was number 1, and I'll just show you. Yeah, let me go into.
Is there really 2,000 codes?
Okay, let me look. I'll find it for you. Delta error codes. I will post this one. We were getting file number 1, which says file does not exist. And that's okay. So that made sense. I hadn't loaded the file. So of course it couldn't run, but it's pretty extensive, which is one of the reasons I post it all, because it may not make a whole lot of sense. But I'll go ahead and post that up as well.
Okay, thank you.
Hey, Tracy.
Yeah.
When you download the program, do you save that in CCAM or do you save that in G code?
When I download the program, which program are you referring to?
Program that we just did today or this evening.
Okay, so let me see if I'm following you. So again, I'll share my screen.
He's talking about the tool pass, Tracy. When you download the tool pass, the project file for the tool pass, is that a CCAM file or is that a G code file?
Okay, so the CCAM file is all the information that creates this project that you're seeing. The G code file is what we generate and download and put in the machine. It's just the G code. And what I'm going to do is I can take this. One thing that's nice about CCAM Pro is that you don't have to save the file. It saves automatically. So if I come in here to file and I say export the project, and then I just save this out, it'll be labeled as export. Then you'll be able to open that up in your CCAM just by going import project and select that file, and you'll have everything that I've got here, and you can generate all your G code and kick it out and everything. Okay.
Yes, but when you do that, when you download that into the machine in a Mach 3,
yeah, all that's going into Mach 3 is G code. And the only thing that's going into your, when you open a code on your system to run a program, it's all just the G code and that's it.
Okay, thank you.
Right.
Where did the parts get saved? If it automatically saves, where do they go? I mean, is there a file location?
Yeah, there is. If we go into documents and go into CCAM Pro, here's projects, and all the information for each one of the things is all in here. Okay. So it has the scripts, it has everything. You won't be able to read this at all. The CCAM Pro has to read all this information, but that's where it's saved, is in projects. Now, if you go to my G code, you can actually save code into here if that's where you want to save it. I saved it directly onto my flash drive. My parts are in here if you save any parts, and so on. So, but everything that you're going to see that you'll import will come out of this projects folder right here. That's where it's going to save it to.
Okay. Well, the reason I was asking is if you had to wipe your computer like I just had to last week, and you need to get in and make sure you had everything saved, I wanted to make sure I knew where everything was so I could get it all.
Okay, perfect. Then what you can do is just go to your documents, to your CCAM Pro folder, and just save that whole folder. Just put it on a flash drive or whatever, and then you'll have everything. The one thing you got to be careful of, let me show you one other thing real quickly. You do want to be careful because you can get messed up. If you save everything in here and you're saving everything in the configs, and you take that and put it on a different computer, it will think it's in demo mode. Okay. So if you're going to put it on a different computer or format your 4 drive, save this folder, because then you go pull all your projects out of here and any of your G code or your parts or things like that, but reinstall it from the flash drive. Because if you try to do it from here, it will kick it out and say it's a demo version, won't generate any G code. So you install it from the flash drive because it's licensed to that flash drive. And then you can come in here and save this display table folder and go put it back into the new documents folder for CCAM Pro.
Is there a problem of us saving that in a cloud file?
Saving the what?
Saving that whole document in a cloud file. Instead of on the hard drive, have it up in a cloud, will it?
You could back it up to the cloud, but it's always going to read out of that drive. It automatically saves into that drive, into that folder rather. So it's not a bad idea to copy that, back it up onto the cloud so you have a backup, or put it on a flash drive or whatever, but it's always going to save into that folder.
Tracy?
Yeah.
I just sent you a spreadsheet on those Delta error codes that I added another column for explanation. Because like a 908 servo error with a 908 error, it's if you're on a limit light.
Okay, great. And you added the explanation in it?
Yeah.
Oh, beautiful. Well, then what I'll do is I'll switch out, I'll take yours and post that one instead of what I've got. And if I have to add it to the rest of the drives, I'll add it all in there. So, all right, perfect. Appreciate that very much. Well, I think we've done enough damage today. Okay, go ahead.
I have an off-topic question. I've noticed when I'm watching your machine behind you that everything it does is in right angles. For instance, it'll pick up tool number 1. From where I'm looking at it, it'll go way over to the right side and then come straight up to the tool pad. On my Maverick 3x5, it goes diagonally. It always takes the shortest path. Is there any reason for that?
Well, in the Delta, the reason for that was because the Delta was designed to start with around the auto tool change. And so we had to make sure it would come out in the X and clear and then go over. And we were trying to get around parts. We could make it go directly to, interpolate the line so it goes directly to the shortest path like yours. Mach 3 is set up that way. Delta is not. It's just the way we did it to make sure that we don't crash into a tool holder or something like that.
Outstanding.
Okay.
Tracy, I got 3 questions for you.
Tracy?
Yeah.
I just wanted to thank you for staging a catastrophic failure on your machine to make us feel better that when we happen to crash a machine, it's not such a big deal. And
I love it. Okay, no
Flying
problem.
an airplane, you don't double check your checklist before you turn it on.
I have a checklist for it too. I did not follow my checklist. And that's what happens when I've got 2 things going against me. Number 1, I'm backwards. I'm not looking at the machine. Number 2, I'm talking while I'm working. And number 3, I'm getting old. So I got 3 strikes.
Still got a ways to go to catch up with me.
Right.
Tracy,
Yes.
along the same lines, I'm a newbie amongst a lot of these folks, but this is just an awesome set of software. And I really feel privileged to be able to watch you go through it and debug it and show us how to use it. I mean, it's what you're all about.
Well, thank you very much, Alan. That's awful kind. By the way, I'm anxious to kind of see what you end up with doing out there in your shop. And if you have any, any questions or you want any input or any help, let me know. I'd be glad to help you out. I'm excited about your program. That's awesome.
Well, we're getting ready to start it. We're finally finished the room and got things going. And so I'll keep you up to date.
Okay. You'll notice I have a Oneida dust collector back there. I haven't set it up yet like yours, but you inspired me to do that so I can start collecting some dust again instead of making a big mess.
I asked Oneida for a finder's fee.
Yeah, definitely. By the way, Alan, he's in a complex and he has taken a 3x5, tore it apart, set it up on an edge, put it in an elevator, took it upstairs, wandered it through into a room, and set up a shop that has 2 different rooms in it. It is absolutely amazing, and he's providing that to everybody that lives in the complex, and he'll be doing lessons and teaching and things like that. So I'm really excited about what he's got going on there. It's awesome. Appreciate it.
Are you kidding me? He actually tore it apart?
He took the gantry off and set it on its edge, put it on a dolly. I don't know how he got it in the elevator. He had to take some doors off the elevator so that it would fit the interior doors off the elevator. It was pretty insane the way he did it, but I got to hand it to you, Alan. That was pretty impressive.
It wouldn't have happened if you hadn't approved making the special wiring harness.
Oh yeah, that's right. We did set that up for you. That's right. The shop did a good job for you. That's great.
Tracy,
all right.
Questions for you before you end. The class review, can we download those at all since they're Zoom or something? We used to be able to go to YouTube and get them. The next thing is tell Chris thank you for sending out that email saying that things are posted now. That's really helpful. And the third, you were going to contact Magnate to see if they had some kind of discount program for this little table for the bits. That one fire hole is like $50.
Yeah, I'll do that. I'll put together this list. The only thing that I haven't done on here is we're going to experiment with the fluting on those tapered legs. And now that I've got the negative number, now it's positive, it should come out correctly so I can do the fluting on it. But Mike's built that so that you can set the flute deeper on one end than on the other because the part gets smaller, so the flute will get more narrow and it'll leave spacing more even between it. So I want to experiment with that a little bit, and then we'll come in and probably throw that into one more class. Once I know that, I'll put together the list of all the bits. We'll get with Magnate, see if we can. They'll offer a discount package. Basically, anything we ask for, they'll do because we provide a tremendous amount of leads for their business. So they love us. It's a pretty good
Maybe
win-win.
I did call and talk to I did call and talk to a Nick over there and told him what was going on, and he didn't know anything about it. And I also sent you an email, Tracy.
Okay. Yeah, Rick doesn't know anything yet because I haven't given him the list, but I will contact him as soon as I know which bit we're going to do the fluting with. I'll package that all together and we'll get the price. Okay.
Maybe they'll throw you a 2704 in there for free.
To replace this one. Now I just need Craft Supply to give me a replacement set of jaws for the chuck.
Tracy, one real quick question.
You bet.
Cleaning the rack. Well, how do you clean the racks?
Okay. Okay. So if you want to clean the rack, what I will typically do is I'll use a Dynaglide and spray on the, once they are clean, I'll spray them on there because then it makes them wear real nicely and it makes it really easy to clean. But I just use a rag and just kind of, you go with the gearing, up and down with the gears on it. That's how I clean it. And if you use Dynaglide and not something with Teflon or silicone, it won't collect the sawdust, so it won't pack in, it won't get wet. If you use WD-40 or anything with silicone or Teflon and spray it on those racks, it's going to collect dust and pack it in. So use the Dynaglide, it's going to be the best thing for you. Oh, one thing I forgot to bring up, and I should have mentioned it when I was going over the photo. We have put together the kit, which has the two domed decals that go on here, as well as the ring. And so that if yours didn't come with it, which originally they did not, we were measuring by the angle, the degrees, and then we added this later. There is a cost, unfortunately, to go with it because we got to build up a big stack of inventory for these. We have enough to fill a few orders now, but we'll build more. But here's what they've got: the package with the ring and the decals and everything is going to be about 40. I'll get an exact amount, about $40 for everything. And then the way we attach this ring, and I'll shoot a video on this. We attach the ring right directly to these rails on the sheet metal here, and I mark the position, and then I use double-sided tape. So if you already have the double-sided tape, that'll work. If you don't and you want to order some so that you can stick these down, then you can use that same double-sided tape to attach your parts as well. I'm sorry, I'm not sharing the screen. Okay, here we go. Again, you guys got to scream at me if I'm not sharing. So it's got this decal, both of them, and these are, again, domed, really nice decals. They do a great job. And then there's the ring that goes on here. And then if you want to order the tape, you can as well. If you already have tape or use something else, that's fine. But this ring is taped directly to these rails. That's how it's set up. The other thing is, and again, I'll shoot a video. This has got parallax. This is not correct. When you're setting at 0, these two align. The reason that you got parallax is because, as you can see here, that ring is down below it. So when you're directly above it, these two align and you'll actually go from point to point. There's really no need to go between because each tick is only 10,000ths of an inch. So if you're interested in that, go ahead.
Can you put that on the Mark III Gen 2? In the 3x5 Gen 2, or is that just for the Delta controllers?
Yeah, anyone who has, it's Mach as well. All of the G code will generate the number of turns for this particular setup. Okay. The only thing is that if you have an older version, you may not have a 10 threads per inch screw. So in conversational cam, both the regular and pro under the machine database, you will now have a bed adjust TPI, this field right here. It's the threads per inch on your bed adjust to raise and lower it. All of the things we do now is 10 threads per inch. If you have an older version, it might have a 4 threads per inch. It's an Acme screw. You would just change this to 4, and the code will generate the proper number of turns for you. Okay. It'll do the same thing. So no matter which screw you have, or anything else, the only thing that is critical is that you have to have, let me see, can I go back? Yeah, you have to have this type of adjustment with this hand wheel on top. If you've got an older machine like an Artie or something, and it's got a wheel and handle underneath, this won't work. This would only work on Mavericks, 3x5s, 4x8s, and the new stuff. So if you've got this type of handle, you can add this ring in the decals. So if you're interested, just give Cindy a call or send her an email, cindy@legacywoodworking.com, or give her a call, and she can put the package together and get it sent out. We'll probably be backlogged fairly quickly because I got some inventory, but not a lot, but they'll make as much inventory as necessary now that we have all the pricing. Okay. Again, enough damage for today. I'll go ahead and wrap this up, and we'll see you guys all next week.